Good evening, everyone, and welcome to today's webinar presentation. This is presented by the Passive House Alliance United States. You can find us at www.phaus.org. And we're a project of Phius, that's the Passive House Institute US. And Phius can be found at phius.org. And I'd like to remind everyone to save the date for our upcoming conference right here in Chicago, September 9th through 13th. And we have a hashtag NAPHC 2015 where you can follow for updates or subscribe to our newsletter. I'd like to thank our platinum level sponsors, Building Science Corporation and Rocky Mountain Institute. I'd also like to thank our silver level sponsors, Mitsubishi Electric, Marvin Windows and Doors, and Casella Dorkin. And thank you for attending this member benefit project of the Passive House Alliance US. And with that, I am going to hand the controls over to our presenter, Lisa White, the Phius Certification Manager.
Thank you, Katrina. Hello, everyone. I'm not sure I can show my screen here. Do you see my screen, I guess, Katrina?
Yes.
Okay, looks like we're good to go.
Okay,
so for whoever...
I can see Chicago on the background. Are we on the wrong screen?
Yeah. No, we're okay right now.
Oh, okay.
Just the main page. Sorry. I don't have a presentation. We're just going to go through a tutorial of the software, but there actually won't be slides, so that might be a question a lot of you have. There won't be slides yet because I'm going to wait until the next version of WUFI Passive software is released to make a formal presentation and step-by-step of everything with the right screenshots and to make sure everything's up to date. So with that being said, I'll just introduce what I'm doing today. Today is the first of what is intended to be a series of webinars relating to WUFI Passive software. Today will be a very basic introduction, maybe a refresher for some of you that's seen it in CPHC class, or maybe it's the first time you're seeing the software. I'll do a basic run through in the static side of the software for a residential project, and this will actually be a project that is in pre-certification right now. So here's some of the steps on the screen. It's the start of an agenda. There's not much of an agenda. Basically, the software is pretty counterintuitive. Intuitive. You follow the tree structure down, so that's basically the order we will go through until we achieve results. So the first thing I wanted to do was briefly touch on Phius certification. As most of you probably know, we released a new standard about a month ago. Actually, it might be a month ago today, and it's the Phius Plus 2015 standard for climate-specific regions. We have implemented this standard, and around 30 to 40 projects are now in pre-certification under this new standard. We intend to phase out the old German-derived standard by September 2015. So for those of you that wanted to certify under the old standard, you would have to do it before then, and then moving on forward, we will follow only the Phius Plus 2015 standard. A lot of the items I will address today address the new standard. In addition to that, the WUFI Passive software I'm using today is a test version. It is about halfway to being implemented into the new standard. So this actually isn't a version that any of you will have if you're following along. There will be a few different changes, and Fraunhofer's in the process of updating the rest of the changes, and it should be done before the end of April. So some things might look a little different if you were looking on your screen. Also, there's probably questions about the free WUFI Passive software. That should also be released before the end of April, and it'll be limited a bit. It won't have some of the dynamic capabilities that are in the full version, and there'll also be other limitations. The details aren't yet sorted. I don't think I have anything. Oh yeah, with Phius certification, I want to give an update briefly on the project count. Right now, we have about 140 projects that are pre-certified or certified, and there's about 130 additional that are in process right now on pre-certification. So that's a it's growing exponentially, and we're really happy about it. And we've seen a lot of growth recently in multifamily projects, which we're also really happy about. Okay, I think we can get into the modeling software now. So the first thing you need to do when modeling in WUFI Passive is to create a SketchUp model or a Revit model of the project you are intending to model. I'm going to show you SketchUp today. So I will open up my SketchUp model here. So what I've done here is created a very simplified version of the project we're modeling. The project we're modeling is called the Woodstock Passive House. It is in Woodstock, New York. The CPHC is Dan Levy. And again, it's in pre-certification right now. And they're under construction. I believe construction just started. It's almost pre-certified. Here's just a brief overview of what the project looks like real quick. It's basically just a rectangle here. This is a garage over to the side, not part of the thermal envelope, so it's just we're looking at this part of the house. The first floor, second floor. There's a section here, and the SketchUp model that we create needs to go to the exterior boundary of this insulation. So we're always going to go to the exterior boundary of the insulation. This is no different than we've ever calculated the area of a wall or area of a slab or a roof. We always go to the exterior dimensions. So that is what has already been created in SketchUp. There is a plugin for SketchUp that allows you to bring this 3D model into WUFI Passive, and I already have that. And with this plugin, you're able to assign properties to each component within SketchUp. So, for example, this wall here, I would assign the WUFI Plus properties to opaque, and then I need to set zones or climatic conditions on each side of the wall. So the inner side, which is the opposite direction the arrow points, is zone 1. We're going to do a single zone model here on a residential project. So we only have one zone to work with. The outer side, the direction the arrow pointing, is outer air. And yeah, that's good. So then, for example, a window, we would choose transparent. So the options here are not relevant. That's if something's in the model that we don't want to go into our WUFI Passive model. Opaque, like the walls, slab, roof. Transparent for any windows or any doors with glass, or an opening, which we won't get to today. So everything has been assigned here in my SketchUp model. So you would create the model to the exterior dimensions. Again, it's a very simplified model. Everything is one plane. A window is just a rectangle on a wall. It's very, very basic. Once this is all done, we would go and we'd save our geometry in our plugins. So that there's say extensions or plugins depending on your version of SketchUp. You go to the WUFI Plus plugin and you'll save the geometry. So this becomes a WUFI Plus geometry file. So I have one saved here. It's a .wps file. I'll just save it as the main house geometry. Save. Okay, so the next thing I'm going to do is bring this 3D geometry into WUFI Passive. So I'm going to open up the software into a clean version, or clean slate here, and I'm going to open the geometry. So I'm going to go to File, Open, and I'm going to browse to wherever I saved that geometry. And I need to make sure to select WUFI Passive SketchUp geometry files down here on the right, or it will not show up. So now I find that and I open. And there is the 3D model. It has brought the house into WUFI Passive. And you can open it, look at it, make sure all the windows are in there, rotate, do all the fun things you want to do with the 3D model. Okay, so now that I have WUFI Passive open, I'm going to go through the general structure of the software. There's 4 screens. The top left is always the navigation tree, and there's different components within the navigation tree, and this is what we'll be going through for the rest of the webinar. The top right is the input screen. So as you click on different branches within the navigation tree, the input screen changes. The bottom right is either errors, where it says the data is not valid for what you've input, or once you've completed the model and input everything correctly, you get results down here. And then the bottom left is always the 3D visualization. As you saw before, you can increase the size of this and make it full screen just by clicking this window here. Okay. Let's see. So the first thing I'm going to do, oh, one more thing I wanted to add. There's this options tab up here, or option here. One thing that's really important, or I would suggest everyone with WUFI Passive does, is go into these options and add all these tooltips. Check the boxes for these tooltips. Phius adds tooltips, so they're like mouse over hints for all the inputs in your screen. So say you're stuck on something, you don't really know what goes in it, or it's unfamiliar to you. If you hover over it with your mouse, these tooltips will pop up if you've checked these boxes. So this is important. Okay. So now I'm going to start to actually input the project data. Okay, so on the case level, I'm going to name the project, it's .ph, and I'm going to change the certification criteria to Phius. This is something new to this version of the software. This is not in the old software. The new update will have Phius certification criteria, and it will calculate for the climate-specific criteria. And that is the next thing we're going to do. We're going to follow the branch down to the localization/climate tab. And over here, you'll also see some new inputs for space conditioning target data. And now you see some inputs that were not here before. If you're familiar, these are the inputs that are used to calculate the specific heating and cooling demand, heating and cooling loads per climate. So what I'm going to do is input these for my climate, for the climate of this project. These will eventually be implemented into the software, but for now, you'll be able to choose your location from a drop-down somewhere, and it'll automatically input these. But for now, I'm going to input them. So I have this down here, and I'm just going to fill this in. Based on my data over to the side. This data, again, will be available if you need this data right now. Well, right now, there's the clickable map online, and no one should have this version yet. And before this version is implemented, we will have this data available to everyone. This cell right now has a slight bug, so I need to input that rather than the actual input. But it will be fixed with the next version, the real version. Okay, so now that I've input my climate-specific criteria, once we get results, we'll see what the actual targets became based on these criteria. The next thing I'd like to do is import climate data. So this is the same as the old software. So I'm going to choose user defined here, and I'm going to browse to the climate data that I'm using. This is available under the Phius website right now, about 1,000 climate data locations. So for this particular project, we're using Occupancy, Dutchess County Airport. And you'll see that now it pulled in all these values. You can look at the climate tab and kind of get a general feel for the climate data, see if it looks correct. It's about lows in the 30s, or well, it's the 20s, and then average monthly temperatures in the 70s in the summer. Primary energy factor, this will choose USA for, and if you have the old version, you'll see the electricity mix was 2.7. This has been adjusted to 3.16 per the Phius 2015 protocol. Everything else should look the same. So now back on the main page, all of this data was pulled in from the climate data set. And eventually, like I said, this will be pulled in too. The only time you would input something in this blank cell is if the altitude of the building is significantly different than the altitude of the weather station. And for this project, we're going to say it's not. It's around the same. Down here, these are usually not to be messed with. These are defaults, and for certification, we like to see defaults like that. Most times you don't, unless you get your soils tested or things like that, you don't actually have values for these either. So I would leave these at default, and that's what we're going to do now. Okay. So the next thing we're going to do is just follow this tree structure down again, and we're in the building level. This gives you the option actually to build within the WUFI Passive software rather than Sketchup. I rarely do that because I'm familiar with Sketchup and I think that's easier to use, but you actually could create your whole building within the building wizard if you'd like. We're not going to get too into that today. That could be its own webinar on its own, so maybe it will be down the road. What we are going to do though is make sure the orientation of our building is correct. So I'm going to open my 3D visualizer, and then over here on the left is a compass, and it's saying south is pointing this way. Now I need to check that with the drawings, and I believe that is opposite of what it should be. So the south elevation is quite a bit more windows than I just saw here. So it looks like I need to flip this 180. Yep. So the north is pointing the opposite direction right now. So I will do that. I will do that by saying change orientation, and I can either just drag this. Oh, maybe I can't drag. I can drag if I change to azimuth. Or if it's a main orientation, if it's in line with the cardinal directions, I can do that. And I just flipped it 180 degrees. Actually, now I flipped it 180 degrees. So now we can go back into our 3D visualizer and see that south is actually pointing in the south direction. So that's all I'm going to do within the building level. The next level is your case level. This is where you input information about the whole model. So I'm going to go through these briefly. Building category, residential. We won't be changing most of these. Occupancy, also residential. There's also commercial options. Building status, we're going to say in construction. It's mostly informational data. Type, new construction. Indoor temperature, this is the temperature during the heating period. So as most of us should know, the threshold for passive buildings is 68 to 77 for the interior temperatures. So 68 will be the indoor temperature during the heating period. Internal gain setting. This is something new in the Phius Plus 2015 standard. Previously, you could use a default internal gain setting, which, as you can see, this hover over hint here says was 0.67 BTUs per hour per foot squared. This is kind of known to be low in most typical projects. It's conservatively low in a heating-dominated climate, but it doesn't necessarily work out when you're not only designing for heating-dominated climates. So something we've done with the new standard is we require that you calculate the internal heat gains. Along with that, we require that you use a design mode for occupancy. There was previously this default internal heat gains and a verification mode for occupancy. The verification mode of occupancy said that there was one person per 377 feet of square foot of treated floor area. This could match your project, this could not. Before, if it was off by a factor of 2 from your project, we required the calculated internal gains, but now we require it for all projects. So I'm going to go ahead and change that to calculated and change this to design. The number of occupants gets entered later, and it'll show up here later, but it is determined by the number of bedrooms plus 1. And if you're in a multifamily project, that's number of bedrooms plus 1 per unit. So that's also where these units come into play. If it's a multi-unit building, you would increase the number of units here. At the bottom of the screen, you see that it has a list of zones. It's pretty simple for this residential project. There's one zone, so I'm just going to call it interior. And later we'll enter the floor area. The next tab here is additional data. This is the preferred minimum indoor temperature for night ventilation. So this means if you open your windows at night, how cold are you going to let it get in the summer? So we're going to keep that at 68. Overheating temperature, this is the 68 to 77 threshold, so we're going to keep that at 77 as well. We don't want to get it any warmer than that. Fresh air per person, this is 18. That's just a default value for residences. You can see again that these hover over hints are really helpful. It's told me these first 3 inputs already. The infiltration, this is something new too. So this is your air tightness basically. There's 2 ways you can input this in this new version of the software. You can either do the volumetric, which is how many air changes per hour is your building leaking at 50 pascals, or you can do an air tightness coefficient for the envelope. So that's how many CFM per square foot of envelope is the building leaking. And this is again at 50 pascals. I'm going to choose this envelope airtight coefficient because that is how the new standard is set up. We are testing for 0.05 CFM per square foot of envelope or less. So this changes quite a bit for smaller projects. It allows you to go quite a bit above the 0.6 air changes per hour, but for the larger projects, it shrinks that allowance there for you. It can get down to 0.3 for some of the larger projects I've seen. So it kind of levels the playing field. So here I'm going to put 0.05 CFM per square foot of envelope because this is the maximum allowance. Okay, the net air volume for the pressure test, we should all know what this is. It's just the total volume of air inside the house. So I have this recorded. This was previously calculated. So this is 18099 feet cubed. The next input is the type of ventilation system. This project is in New York, so they will need an ERV. They're going to need heat recovery, which is common for most climate zones in the north or in the US. So I'll choose balanced. The next option here is the summer night ventilation. This is kind of what I was talking about earlier with opening the windows, or there's the option of a whole house exhaust fan perhaps during the summer. At night when it might be more desirable temperatures outside than inside, the inside's heated up over the course of the day, and then you can actually night flush and take advantage of that passive cooling. So this project doesn't have any fancy mechanical controls or fans, but the occupants will be opening the windows at night for some night flushing. So I'm going to choose manual here. This next value is the maximum humidity ratio. How much water are we going to let build up in the air before we need to dehumidify inside? This is the default value again. The building wind exposure is next, and this is basically, it's almost always moderate screening for like suburban type of situations. No screening might be some sort of situation where you're just in the middle of the field, in the middle of nowhere, and you get really high winds, or maybe you're at a peak of a mountain or top of a hill or something. And high screening might be some sort of situation like in the middle of the city, where you have buildings really close to you on all sides. These one-side exposed are usually only for like if you're modeling an apartment unit that may be on a corner or just may have like a front face exposed, and that's when you'd select that. As you can tell when you select one from the drop-down, these other values change. If you think you're somewhere between maybe no screening and moderate screening, you could input user defined here and input your own values. But I'm going to choose moderate for this one. It's kind of in the middle of a foresty area. Okay, the bottom is all optional data. We're not going to input any of that, but I'll go through it very quickly. This is a PV input. Right now, you can tell the hover over set it's for information only. It will be implemented in the new version, but as most of you know, PV was not counted previous to the Phius Plus 2015 standard. So we're going to input that as 0 right now. The hot water consumption, this is at 140 degrees. This is 6.6 gallons per person per day. Again, if you don't input anything, it will be input the default. Average cold water temperature of the supply water. If you don't input anything here, it takes the average ground temperature. So I usually just leave that blank. I think that's pretty accurate to use the average ground temperature. Or you can input 50 degrees. And then the mechanical room temperature is always set to 68 if your mechanical room is inside. Okay. Next thing I'll talk about here is the foundation interface. This is kind of how your building is connected to the ground or not connected to the ground. Something cool about the new version here is you can add multiple ground conditions. So this is new to the new version of WUFI Passive. I don't even think multiple ground conditions was ever fully implemented in the old modeling software, so this is pretty neat. I'm going to name My foundation is slab on grade, and we're going to take a look at it really quick. So pull out my section really quick. Okay, have that ready. So it's a slab on grade here. These are foundation walls below grade. Okay, so the setting, I'm going to choose user defined, and I'm going to choose slab on grade. So you can tell as you pick different drop downs here, there's different information the model needs depending on what type of ground condition you have. Or you could have none. Again, this could be like an apartment that's on the 3rd floor, something, and they're not actually connected to the ground. They have adiabatic conditions beneath them. Okay, so for slab on grade, I'm going to let the model pull in all of this information for the floor slab area, the U value of the slab on grade, and floor slab perimeter. It's not showing up right now because we haven't defined enough about the model, but I promise by the end, all of these values will be automatically pulled in from the 3D visualization, which is pretty cool. It knows this because we assign different parts of the building as connected to outer air or ground and things like that. So it's pretty helpful that you can let the model just recognize those different components. Additional parameters, though, are things that we haven't modeled, like perimeter insulation, so we will need to define those. So if I go back to my drawing here, here's the perimeter. So it does have vertical perimeter insulation over here, as you can tell. The depth that we're looking at is beneath the actual sub-slab insulation, so it'll be this 2'10" here. It thinks right now that the slab extends with this insulation all the way out to here. It's the way the areas are input. So we're going to do everything additional to that below that. Looks like it's about 6, well, that's 6 inches, so maybe it's 8 inches thick. So we're going to select vertical insulation. The width/depth, this will be the depth, the 2'10". This is input in feet. Kind of tricky here because the others are inches. So I'm going to do 2.83, I believe, feet, which is 2'10", and then the thickness I said is about 8 inches. The conductivity of perimeter insulation, we're going to just input an R per inch because my brain doesn't work that way, these other units. So I'm going to select R per inch, and I'm just going to say it's R, it's foam glass, so I'm going to say it's R3.6. I think that's what they're using. So this actually appears a lot. If they're asking for conductivity, there's actually a box to input R per inch. So now we are done with the foundation interface tab. This is actually more optional data that we are not going to input. So this completes the PH case branch. Now we go into our zone 1. This again is the entire building. We only have one zone. So it should be simpler than if you were doing a multi-zone model. Okay, so the reference volume here, or I guess I could start at the top here. The name, we've already named the zone. It's a simulated zone, which means we're actually trying to figure out the conditions for calculation or simulation. An attached zone might be a garage or something that you're modeling, but you don't care about the heating demand, cooling demand, and all of it inside, but it's in the model. And then we're in our only PH case. Okay, so this is kind of information about the geometry. The first input here is the reference volume. Well, you're safe to always choose visualized geometry. The reference volume is the volume of your reference 3D model. So it's going to take the volume of whatever you've modeled to the exterior dimensions and everything. Because we model to the exterior dimensions of all the insulation, we are able to also choose our gross volume from the reference volume. So the reference volume should always be the gross volume when we're using when we make our SketchUp model to the exterior boundary of the insulation. If we use the interior for some reason, then it wouldn't actually be the gross volume. So we need to always make our SketchUp model to the outer boundary of the insulation. So that is my gross volume. The floor area here, this is something also new to the Phius Plus 2015 standard. This is the interior conditioned floor area. And actually, I'll just pull up a quick definition of that. guessing people might want to see it really quick. Okay, so it's all floor area of interior space at least 7 feet in height, measured from the interior finished surfaces that compromise the thermal boundary. So, or comprise the thermal boundary. Yeah. So, in my project, near the Woodstock Passive house, we have takeoff drawings of the interior conditioned floor area. You'll see instantly that this is significantly simpler than the treated floor area. Simply take dimensions from the interior gypsum here. Staircases count on both floors, projected area of staircases. And there you have it, that's the ICFA. We're not taking any reductions for mechanical rooms, for half-height spaces. It's either it counts at 100% if it's 7 feet in height, or it doesn't count at all. And this is what the new standard metrics are also based on. So for this project, the ICFA total is down here, 2373. So I'll go back into my model and I will input that. The reason I can't just choose this from the visualized geometry is because you can see it's about half of that. We haven't built that floor into there, so it doesn't know about the second floor. So the interior conditioned floor area will almost always be user defined. So I'll keep that input. The next input is the clearance height. Again, this is another that you really don't change. It's a standard value. It determines the ventilation volume right now. So the average height of indoor rooms, 8.2 feet, about 2 meters. That's where that derived from. Okay. The next value is the specific heat capacity, or how much thermal mass does this building have. This building happens to be built with autoclaved aerated concrete, which has a pretty good quality of thermal mass. And open this section real quick again. It doesn't have insulation on both sides, so this autoclaved aerated concrete block here can actually work pretty well as thermal mass. So this is open to a lot of the rooms here, and as well as the slab. So there's some heavy surfaces here. So if anyone's seen this equation before, basically you determine the number of heavy surfaces enclosing each room and determine the thermal mass of the building and the heat capacity of the building. So I'm going to say this building is mixed, and if we were to do the calculation, we'd get about mixed here. Again, the calculation's in this mouse overhang, and it's also in the certification packet. If you think you're somewhere between lightweight and mixed, for example, this happens a lot actually, you could input something between 11 and 23, maybe 18. But for this project, I'm going to say it's mixed. Okay, so this is all we need for the zone 1. Yeah, so now we're going to get into actually creating our visualized components. And I'm not sure if Katrina mentioned it, I don't think so. I'm not sure if I'm going to take any questions until the end, just to make sure we get through everything. So I apologize if people are asking questions. But I'll try to get through everything and then answer as many questions as I can. And I can answer things via email afterwards too. Okay, so the visualized components, break this out. Right now, everything in my model is grouped to other light components. So all my walls are grouped. You can see here. The selected walls outlined in red, the rest are outlined in yellow. All my windows are grouped, and then my roof is grouped, and then my slab is its own component down there. So I only have 4 components right now. So the first thing I'm going to do is add a name for each. This is my walls, this is my roof, slab, and windows. Okay. So the next item is to show you how to create an assembly, an actual wall assembly, and we're actually going to model the AAC block with the mineral wool here. There's a couple ways you can do it. One way is within the project level. I rarely do this anymore because I don't find it to be too helpful. I create everything within my database, and therefore, when you do this, you can open it up in different projects. So if I were to create a wall in here and spend some time adding the layers and everything, it's only within this project. I can't access it again. If I create it within my database, I can access it again. So I would recommend just making a habit of creating a database of assemblies and windows and all of that, so you can spend less time doing that and spend more time optimizing the building once you're actually modeling. So I'm going to go into my databases. So along the top left hand over here, there's a database drop down, and I'm going to go to assemblies. This brings up a new screen. This is my assemblies database. There's different databases for the windows, materials, HVAC systems, all of that stuff. So you can see over here on the left, I've created my own user-defined database over here called Lisa, and I am going to create a new database within mine for this Woodstock passive house. So I will do this by selecting user-defined from the scope, clicking my name, and then adding a new database within that. So I'm going to call it Woodstock. That's fine. Okay. So now that I have my new database, this middle screen is where you actually create the new assembly. So you can see in my other databases, these are where the assemblies actually show up. So I'm going to go to the new block in this middle screen to create the assembly. Okay, this is usually the order I follow. I write the name of the assembly we're doing. So we're going to start with the wall. And then I usually am pretty descriptive about the assembly so that I don't have to look into too much detail to figure out what each one is. So this wall, I believe, is just gyp. Over here, we have some plaster, we'll call it gypsum, then 8 inches of AAC block, and then about 6 inches of Roxol rigid mineral wool. So that's what is going to comprise our assembly. So I'm just going to call it gyp. Actually, I'm going to go the opposite direction. So 6-inch mineral wool board, 8-inch, 8-inch AAC, half-inch gyp. You can just call it the Woodstock wall if you wanted to, because you will see the different layers once you open it, but I find that helpful. The next thing to do is go into the Catalogs tab and actually assign it to that catalog. If you don't, it'll still be created, but it won't be within the specific project catalog. You'll have to search for it within all of the other assemblies. There's also an option here for description. If I wanted to say, like, I'm making this in the WUFI Passive tutorial on 1415. So if I come back to it and I wonder, where did this come from? Okay. So this is the screen for creating an assembly. This is where the different layers of the assembly go from outside to inside. This is the visualization screen. And this we won't really get into today, but this is if you're creating different framing layers within the assembly. So my first layer from outside to inside is going to be the mineral wool board. So I'm going to select new. And I usually just start searching up in this top. So I put in mineral, and I find here mineral insulation board. So I'm just going to pick that and apply. This is probably a good time to mention that when you're looking through the material database to determine what you should use for your project, in the static side, the side that I'm in right now, the most important value is just the conductivity, or the R value. All of the other information gets important when you run a dynamic simulation, but it's not quite as critical for the static energy model. So right now I can just pick this mineral insulation board, and if I want to, I can adjust the thermal conductivity within the project level, not within the database level, because I don't have the rights to change this material data within the database level, but on the project level I can click in and make this whatever R value I want. So I just selected the mineral insulation board. So it's usually, you select something close. It could be like R3.5 and I'm looking for R3.7 or something. Okay, so the next thing I'm adding is the AAC block. So I'm going to select new here, and I'm going to look up aerated. So again, there's lots of different types here, but what I'm most interested in is the R value. So I know this particular project, it was about an R1 per inch, which is about 0.081 thermal conductivity. So I'm going to select this material. I'm going to change the thickness to 8. And then the last layer is the gypsum board. And I'm just going to pick USA. Put a 1/2 inch in there. And that is my whole assembly. It's not very pretty. The colors aren't very contrasting for this one. But that's your assembly over here. And you can see up in the top left here that the R value is about 29. And that's it. So we select OK. And now within my woodstock catalog, I have this wall. Now I'm going to create the roof. I'm going to go back to my drawing. And I'm going to look at what's going on here with the roof. So it looks like there's 22 inches of cellulose. There's 1.5 inches of mineral wool board under that. And then there's a 1/2 inch of drywall. So I'm going from outside to inside again. And I'm labeling the different materials. Again, you can name it whatever you want. This is just a personal preference. I'm going into my catalog, selecting woodstock, and now I'm going to add these layers. Do cellulose. I'm going to pick this one. See, they don't really vary too much in the thermal conductivity. It's the density here that's changing. So pick that, 22 inches. The next layer, I'm going to pick that same mineral wool board. Mineral insulation board, 1.5 inches, and then I'm going to pick gypsum again. Some of you might be wondering, what about the framing? Right now, that's pretty hard to model within the roof, but in the next version, we should have a framing percentage that you can input. Right now, you're able to add vertical and horizontal subdivisions, which work for materials that are perpendicular and parallel to your assembly. But if, let's say, you have like scissor trusses or something that's, diagonally moving through here, it's not very easy to model. So we're not going to do anything about it for the purposes of this webinar, but I'm sure in the future we will get into that level of detail. And now, again, this is our assembly. Not every material is gray. That just happens to be what we selected so far. Okay, and now, yeah, we've got an R94 roof. So the last thing we're going to model is the slab on grade. So we go back into our section. Looks like we have 6 inches foam glass and 4 inches of concrete slab. So from the outside to inside, we're going to pick foam glass, and I already know it's not in here. The only foam we have is a spray foam. Oops. So I'm going to pick EPS. It's pretty different in terms of the actual composition of the material, but what we're looking for, again, is just the R value. So yeah, the density of foam glass is going to be significantly higher than this, but we're just going to pick this value for the EPS and use the R value from it. What we could do, if we wanted to run a dynamic model, is actually find the information for foam glass and create a new material within our material database. I'm not going to do that today because we will run out of time, but that is something you can do. Okay, so we have 6 inches of foam glass under the slab, and now we have a 4-inch concrete slab. I'm just going to pick regular old concrete. And 4-inch. I realized I didn't name that, so I will have 6-inch foam glass, 4-inch concrete. And I'm going to call that slab. I'm going to put it into my catalog. And there's our assembly. It's about an R22 slab. It might be a little higher. The foam glass might be a little better than that EPS I selected. Okay, so now I have an assembly for my roof, my slab, and my walls. And thankfully this project is pretty simple. And it has one wall type, one roof type, and one slab type. It's kind of rare for that to happen. Usually there's at least like an underground wall or something's changing. Okay, so now I'm in my assembly database again. I've created everything I need to create, so I can just close out of this. So now I'm back into my regular WUFI Passive screen, and I need to assign my assemblies. So before I'm going to do that, I'm going to show you briefly how this general screen works for the different components. I have my wall selected, and right now it tells me my orientation is all 4 directions, but that's because they are all grouped. So let's say I select my roof. Yeah, okay, it says it's only horizontal. If these were broken apart, you would know which orientation was which. These percentages represent the amount of area on each wall. The reason south and north aren't equal is because it already subtracts out the window area. So this area you see right here, 872 square feet, is for the north wall minus the windows. So the windows are already subtracted out. So if I were to click on this, let's see, this is the west wall, 680 square feet. That's subtracted the window. This is the total area of the walls here, 2942. Inclination is 90. We know that. Okay, so now I'm going to go into assigning the assemblies. So if I were to do it within the project level, really quickly I'll show you, you would say new, assign, edit. And it brings up the exact same screen I saw, minus the cataloging option and the description option. So you could create all your assemblies within the project level outside the database, but I'm not going to. What I'm going to do is simply say select from database. And now I go from Lisa into my Woodstock database, and I was on my walls. So I'll select this wall here. And it's in the model. So now my walls are assigned to this specific assigned wall that I've created. I'm going to do the exact same thing for my roof. And then you'll see that as you add assemblies, they become available assemblies in this list. And then the assigned assembly is always at the top. So my walls are the wall, but the roof is available. And the roof has the wall available. The slab here, I'm going to assign. And now all my assemblies are assigned. Okay. The next item here is the surface. This top part is for the surface film coefficients. Usually according to component type works. The only time it doesn't. So this is the exterior surface film. This is for an exposed condition, 0.23. There's also the screened condition of 0.45, which is actually what this project would be. They have a rain screen system. But I could change it. But then the interior is 0.74 for horizontal airflow. So usually these are correct based on component type unless you have a screened condition. It automatically defaults to exposed. So I can change these. So for the wall, I'm going to select easier to find, and I'm going to say it's screened, and I'm going to put in the horizontal interior surface condition. I'm going to do the same for the roof. It's a vented roof. So this is also screened. And vertical airflow. Okay. These are really minuscule. If you didn't change them, it would be fine. Adds 0.2 to your total R value. It's not a big deal. The slab I'm going to keep according to the component type. This bottom, absorption and emission coefficients, this is based on the material, or more so the color of the material that you're using. There's all these different options for what you're using. Let's see. I think for now I'm just going to keep it as these user-defined inputs. These are kind of generic defaults. And for this project and for the purposes of this, I'm going to keep it at the defaults, but you could change this. So the absorption would increase if it was black, for example, or dark colored siding, black roof tiles, that sort of thing. The reduction factor for shading, this means how much shade is on your walls. So how much is the shade going to affect the ability for the walls to absorb radiation. I'm going to keep it at 1 right now. Usually it's like 0.8, 0.9, something around what your windows are, depending on your situation. So I'm going to keep it at 1. And the slab doesn't have that because the slab is obviously in connection with the ground. Okay, So next, I'm going to create my window in my window database. Most projects don't just have one type of window. Usually have a fixed tilt and turn or operable, usually have a door with glass, things like that. For the purposes of this tutorial, I think I'm only going to have time to create one or maybe two windows. But in your usual project, you would break these up into individual components. Maybe a bigger multifamily project, you could start grouping windows. But for this project, I would expect to see every single window as its own component. For a couple reasons, usually one of these is fixed and one's tilt turn, and because shading can differ. So I wouldn't want to group like this with maybe something over here if there's a tree over here, something like that, or an overhang. So you can see on the elevation here, there's an overhang, or there's a porch out here in the front on the first floor. So these windows are going to be shaded differently than these windows. So you really don't want to group a lot. I would recommend not grouping at all, but sometimes grouping saves time for quick models. So I'm going to go into my window database now. So this window database is completely separate from the assembly database. So you'll see down here I have a Lisa database, but I don't have, oh, I'm in the materials. There's windows. I have a Lisa database, but I don't have that Woodstock sub database that I had created earlier. So I'm going to do that now. I'm going to select user defined, and I'm going to say new catalog within Lisa's catalog. Next, I'm going to pull open my Phius certified window data. So this is something to note too. If anyone's done a project in certification within the past couple years, you might be used to this structure. This is the Dropbox structure for submitting a project for certification that I've kind of saved this project into. There's different folders, and this is what I'll be navigating through. So now I'm looking for windows and doors specifications. So I'm just going to open the two Intis Phius certified window data sheets. One is for fixed and one is for tilt turn. So we'll go ahead and create both types because it's pretty quick. So the first thing I'm going to do is say new, and I'm going to name this Intis Port. Tilt turn we'll do first. And then I'm going to do medium gain. The medium gain window is what the project is actually using, and the certified window data sheet has the low gain. So I pulled the numbers from Intis for the medium gain, just so we can be a little bit more accurate. So the numbers I'm using for the medium gain are, let's see, solar heat gain coefficient of 0.494. I'm inputting these for all three solar heat gain coefficients here. This is actually the one that's the solar heat gain. These are for dynamic modeling. Good luck finding that data. I'm going to select the detailed calculation for the U value of the window in frame. That basically means that it'll take my inputs and the thickness of frame, U value of frame, etc. to calculate the whole window U value. This top part is for the glass. Should have mentioned that. The thermal conductivity of the glazing I saw on my sheet over here is 0.088. And here's the 494 UVAT or solar heat gain coefficient. So now I've input my glass for medium gain windows. Now I should add it to my catalog. And I'm going to now input data from the Phius certified window data sheet. Let's see if I can pull these up at the same time. Doesn't look like I can. Okay, so this is the frame width. I'm going to take that from right over here. That would be 4.82 inches. This next one's the frame U value. That is 0.2 for the tilt turn windows. That's over here, U of the frame. And the new version should say the U value of the frame. That's a request we had. Installation can kind of be confusing. The glazing frame psi value is the psi spacer right over here. And BTU hour per foot per degree Fahrenheit is 0.023. And the last value is the psi installation value. So that's not really a value that your manufacturer can give you. That's dependent on how the window is installed within the wall. And I'm going to quickly pull up this window detail of how it's installed. This is a pretty good window installation detail. Whenever it comes up. There we go. So this is the outside, this is the inside. Here's the window frame. It's over insulated with this comfo board, the Roxo mineral insulation board. And it's installed in the middle of the wall. So this is pretty good. This is something you want to do. Because of that, we will input a median value for the frame wall psi value. I guess it's actually a low value in terms of certification. In our certification guide, you'll see that there's a couple of values that just based on experience and different calculations of the installation conditions, we will let you input down to 0.015 for the psi install if your window is installed in the middle of the wall and has over insulation. So this project did both. So that's great. And that's the value we'll use. So I'm going to keep that open actually. So this is all we need to fill out the window. So this came from Intus data. It could usually come from Phius certified data. We haven't gotten to that glass yet. And these all came from Phius certified window data. I'm going to say OK. Now to make the fixed window, all I need to do is say copy new, because most of the window information is the same. The glass isn't changing. All that's changing is the U value of the frame and the thickness of the frame. So I'm going to say copy new. I had already selected this tilt turn, and I'm just going to change that to fixed. Make sure it's in the catalog. And now I'm going to keep the glass data the same, and I'm going to change the frame width. So here's the fixed window. Down here we have 2.91 inches for the frame width. So I'm going to put that. Installation U value, the frame U value, this will change. It's 0.022, 0.22, I'm sorry. And then the glazing frame, the spacer might change a little bit, yeah, 0.022 here. And then the installation condition stays the same. So now I have my fixed window, just like that. And I'm going to close now. Again, you would have to create a frame for the door or any other different varying frame condition you had. So the door frame is probably thicker. But for now, we're going to use one frame type just to keep things moving. So I'm going to select window parameters, the second tab, just like with the opaque components, assembly, or window parameters, and I'm going to select it from the database. I'm going to Woodstock, and I'm going to pick, I'll just pick the fixed one, medium gain. And now that's assigned to all of my windows. This is kind of cool too. You can see the percentage of each orientation. So each window you select, you can see the area here. So that red window is 20 square feet. But then also you can see that 47% of my glass is on the south, about 20% on the east, 13 on the west, and 20 on the north. So that's kind of interesting information. Okay. So now that I've assigned all my windows, the next object is shading. There could be a whole webinar on shading, and there might be eventually. So I'm not going to go into too much detail here to make sure we can actually get results, but I will input some accurate data. So once you hit solar protection, you get these new 3 tabs. There's general, sunscreen devices, so like blinds maybe, and window overhangs. So I'm going to start on the general tab. This should all look familiar, these references. Reveals landscape obstructions, and just shading fractions. So what percentage is shaded and what percent isn't. So the window reveal, if most remember, is this shading from the window being inset into the wall. So now let's pretend we're in plan view, and this is the window reveal, this edge right here. So this part of the window is going to be, shaded depending where the sun is. So the window reveal here is at least, let's see, 6, 7.5. It's probably 8 inches, maybe a little more. So we're going to input 8 inches for the window reveal, and that is the depth from here out to here. There's the depth of the reveal, which we have is about 8 inches, and then there's a distance from the glazing edge to the shading edge. So that's from, oh shit, this is a pointer, but that is from here out to here. So this short little distance right here. It says the window's over insulated 1.5 inches. So if we have like a 3-inch frame, let's say the depth, or I'm sorry, the distance is 1.5 inches. So the depth of the window reveal is the first input. I'm going to put 8 inches. The distance is 1.5. The landscape obstructions, there actually are some for this project, but I'm not going to get into that for the modeling here. But there's a tree line in the distance, kind of at the border of the property line. But that would require me separating the windows into different orientations. I'm just not sure we have time for that today. So I would input that there. So if there was a 50-foot tree, is 100 feet away, that's how that would be input. We also use these inputs for solar pathfinder readings. If you know the angle of obstruction, then you can create kind of a false landscape obstruction that shades at that same angle. So what I'm going to do today is just generically say there's 80% solar exposure on all the windows. So it's shaded 20%. And I'm going to do the same for the summer and winter. So this top one is winter, or the heating period, and the bottom one is the summer. And I'm going to call it that. This is not detailed enough to certify the project or even to model it, I'd say, for a client. This is just for the purposes of the tutorial. I'm going to say there's no sunscreen devices. You could add something like blinds here, interior blinds, exterior opaque blinds, something like that. I'm not going to add anything now. In the window overhang, I'm not going to add anything either. I know there are overhangs on these windows right here, so they would need to be broken out and a new window overhung. So I'll show you how I do that real quick. Just sign and edit. And it asks for the depth of the overhang, so how far does it extend, and then the distance from the top of the glass to the bottom of the overhang. But I'm just going to say there's no overhang. When I say there's no overhang, every window that doesn't have an overhang assigned automatically sets the reveal as the overhang. So it automatically thinks there's an 8-inch overhang over all the windows. That's 1.5 inches away, which is accurate in this case for most of the windows. Some do have a dedicated overhang, as we saw. So that's all I'm going to input today for shading. Maybe there'll be questions at the end on shading. But that's all I'm going to input. And it's relatively accurate. Okay, so following down the branch, now we've completed our visualized components. They're still grouped, and that's fine. It's almost always fine to keep the walls and the roof and everything grouped together, unless they're different wall types or different roof types, which is possible. Yeah, we've completed our visualized components. The next thing we're going to do is add the inner loads and information about the occupancy. So the occupant quantity, I guess by default, is 4, but we're going to check the floor plan here to see how many bedrooms there are. So the upstairs, we're going to call this bedroom, so bedroom 1, 2, 3. So the occupants, as I said before, is number of bedrooms plus 1. So it ends up being 4. So 4 was right here. This you should change. If I had 4 bedrooms, I would input 5 here. The humidity sources, this is a default. Again, it's a typical value for dwellings or residences. Okay, so now here's my device list. It's empty right now, but I'm going to add a standard data set by clicking on it, which just pulls in one of everything, one of every type of device. I know that they don't have a fridge, freezer, and a fridge freeze combo, so I'm going to go ahead and delete the standalone fridge and standalone freezer, and we'll just keep the fridge freezer combo. And then, okay, so we'll start by adding information about the appliances, and then I'll get into the lighting and plug loads that has changed with the Phius Plus 2015 standard. So what I've done here, let's see, is I've taken information from different appliances and calculated them to what the energy model wants. So this is all in the certification packet. You find the model number, and then for dishwashers, you find the energy factor, and then there's a certain input you put in WUFI Passive. So I'm going to go ahead and input these based on these different appliances that I've selected. So for the dishwasher, it asks me for kilowatt hours per use, and I'm going to input 1.3 from over here. For the clothes washer, it asks me for kilowatt hours per use, and again I'm going to input the data I got from the manufacturer. So this is just kilowatt hours per year. All of this is readily available for anything that's Energy Star certified, which should be probably everything you're using. Utilization factor, the hover over hint that will come up tells me 1. Here it is. I'll use that. Dryers just started to be being rated by the government, so we've always used 3.5 kilowatt hours per use. We haven't yet developed protocol for this, so for now, always input your dryer as 3.5. I'm going to change it from clothesline to condensation dryer. That's what this particular project's using. There's also options for gas exhaust, electric exhaust. Let's see, drying closets. Remaining dampness is, sorry, this keeps scrolling. Remaining dampness is actually relative to, here we go, relative to the washer you're using and the spin cycle in the washer. So how much moisture does the washer remove before you put it in the dryer? I'm going to use 0.6 here. It's in the median range there. Okay. The kitchen fridge freeze combo is 1.25. Again, I'm pulling this from my spreadsheet over here where I found out it was 455 kilowatt hours per year. Easily translates to 1.25 per day. Okay, kitchen cooktop. This actually is all of your cooking. I don't know why it only calls it the cooktop. But I'm going to choose electricity, and I'm going to input 0.2 based on this hover over hint for induction ceramic cooktop. Okay, so the next thing we're going to get into is lighting, plug loads, and small appliances per person, which we don't really deal with anymore. So with the transition to the Phius Plus 2015 standard, we decided that it would be honest to be more accurate about the plug loads inside of these homes we're modeling. This came hand in hand with the idea to actually calculate the internal heat gains rather than just assume a default. If we wanted everyone to calculate them, then we actually should be more accurate about the lighting and the miscellaneous loads that occur in these buildings. So for lighting, so we've developed this calculator, and this will be implemented within the next version of the WUFI Passive software that'll come out in a couple of weeks. Right now I have to do a couple workarounds. So I have this Phius Plus 2015 calculator. I've input these values. It basically takes the conditioned floor area and number of bedrooms and tells you an assumption. It's a ResNet calculator. I apologize for not mentioning that. It tells you the assumed miscellaneous loads, interior lighting, exterior lighting, and garage lighting. We take 80% of what ResNet assumes. So this already has taken 80% out. See if you're. So we're assuming that the people in these homes are slightly more energy conscious than, I guess, the regular person, but not saints. So what I'm going to do here is choose user defined for all 3 of these down here. And what that does is it gives me the option to input kilowatt hours per year, which is a lot less tricky than these fraction of high efficacy and energy demand norm and the other inputs that we were kind of unsure of. Okay, so I'll do user define. What I'm going to do is add one for each of these. So my miscellaneous loads, I'm going to call this res 80%, resnet, and yells. And I'm going to input the kilowatt hours per year here, so 2224. I got that directly from my spreadsheet. The next input here will be my interior lighting, so the 80% resnet interior lighting. And I'm going to do 784 kilowatt hours per year. Last one will be exterior and garage lighting, and this project does have a garage, so I'm going to keep that. And I'm going to input 64 kilowatt hours per year, sum of 44 and 20. One important thing is that this exterior lighting is not inside the envelope, so I'm going to uncheck in condition space so that it doesn't calculate within the internal gains. So that's a short workaround that will be illuminated again in a couple weeks, but this is how you calculate the lighting and plug loads. This is pretty much it for the inner loads and occupancy with a single zone residential project. So I'm going to move on from this. I guess I can note that you can see down here there's still errors. If I were to click on this, it tells me there's no mechanical ventilation capacity defined, which there's not. We haven't added systems. But I'm past the inner loads errors. So it kind of goes down the branch of errors. So if there were errors before this, it would tell me. So if there was an error with something in zone 1 or something like that, it would tell me. So I can tell that I have gotten far enough that I'm ready to keep going down this tree. Okay, next thing we do is add ventilation in rooms. I'm going to set up a utilization pattern. I'm going to call it standard. This is just year-round, 7 days a week, 52 weeks a year. If I had a different type of project, maybe like a school that had different occupancy patterns and different ventilation patterns for those usage patterns, then we would have more than one utilization pattern. But for this residence, we're just going to set up one. Okay, so the first thing, I'm going to come back to this daily operation schedule. First thing I'm going to do is add all my rooms. So in this list, you add all your exhaust rooms for sure. And I also add supply rooms. I think it's helpful because it sums your CFM and makes sure you've designed a balance system, but all you actually have to add is the exhaust rooms. Once it knows how much you're exhausting, it assumes you're balancing the system and supplying just as much. But I'm going to add all the rooms. So I'm going to really quickly go to my mechanical plan. And I'm going to look at the different rooms I have. Okay, we have it down here too. So I'll probably just pull it from down here, but you can see on the plan they're exhausting from bathrooms, supplying the others. I'm going to save this really quick. Saw a slight freeze, didn't want to lose it. Okay. So the first thing I'm going to add here is, I'll start with the exhaust room. So powder room, bathroom, kitchen, bathroom 2, and master bath. Powder room, bathroom, kitchen, bathroom 2. I don't remember the last. Master bath. So I'm going to change this to water closet. And for each of these, you have to set up the utilization pattern of standard. So I'm going to do that really quick. And I'm going to say this is 12 CFM. And I'm just going to follow whatever the plan has here. So it goes 12, 24, 36, 24, and 24. Looks like a total of 120 exhausts. I've added 0 for the supply for these rooms. And now I'm going to add the supply rooms. Oh, I didn't change these. You can see when I add bathroom, it wants to put 24 CFM, but it's doing a conversion from metric, so it does 23.6. I'm going to change that to 24. And now I'm going to add my supply rooms just to make sure I have a balanced system. So I have 5 supply rooms and they're all 24 CFM. So I have an office, living room, master bedroom, bedroom number 2, and family room, which we considered a bedroom up on the 2nd floor. Office, living room, bedroom 1, bedroom 2, and master bedroom. And I have to choose user defined for all of these because it only has drop downs for exhaust rooms, because that is the only thing it actually requires. But again, I like to enter both. And these were 24 CFM. All of them. Oh, it's not need to do that. Okay, so now you see we have a balanced system at 120 CFM, exhaust and supply continuous. This is the max airflow rate usually. So this is when the boost mode is on, and continuously you can ventilate lower than that. So that's when I'm going to come back to the utilization pattern and set up how often I think it's going to run on max, and then what that airflow will be at maximum. So I'm going to say it's standard, so continuous, maybe it's 0.75. So it's 3/4 of the way to the maximum. Maybe it's 0.5 at basic, and then at minimum, maybe it's 1/4 of the way. For now, I'm going to say, oh, let's do 22 hours, maybe it's standard, and maybe there's 2 hours of boost mode, where in the bathroom or they're just cooking. Soon, we'll be able to see what the actual air change rate is from this schedule once we get our results. So we can come back to that. But we're looking for about 0.3 for a resident. 0.3 air changes per hour. In this room's ventilation, you saw at the bottom, there's additional data you can input per room. You can input the area of the room and then the height of the room, and it'll tell you the air changes per hour of that room. This isn't too useful for me. It might be for you or for code, but I'm not going to input that here. It's just additional data. Okay, the next tab is the summer ventilation tab. The only critical inputs are these 3 at the top. This bottom is a calculator to determine the, feasibility of night flushing, depending on how your windows are set up and the cross ventilation possibilities. I rarely use that, but I think it can be pretty helpful. But for certification, we limit the amount of cross ventilation or night ventilation or flushing that you're able to do, because it's usually dependent on the occupant, and we can't certify people. We can't certify the occupants, we certify the building. So the first input here is the natural ventilation during the day. So maybe you open the windows a little bit during the day. So we'll have 0.1 air changes per hour. We limit this as well to 0.3 air changes per hour. This is night flushing, so additional summer ventilation during the night. We limit this to 0.3, but I think this project set has quite a bit of operable windows and plans on using passive night ventilation. And then this last input is your mechanical ventilation rate. So it's whatever rate you're running your ERV over the year, assuming you run it in the summer. If you don't run it in the summer, you leave a 0 there. But if you do, which most people do, you'll input the same rate as your mechanical ventilation rate, which we'll see over here once we get our results. So I'm good now on the summer ventilation with just these 3 inputs. If I were to fill this out, I could set these values from the calculators below. So that's it for ventilation for right now. We can come back and look at this average air change rate once we get our results. Keep going down the tree. Thermal bridges, there aren't any in this project. Pretty good detailing. Let's see here. There's definitely not a thermal bridge at the perimeter. It's continuous foam. And then again up here. Pretty continuous insulation all around. So thermal bridge free outside of the window install details, which are accounted for within the window parameters. Again, with this porch, it's not bridging the insulation. It's not directly connected to that block. So I'm going to skip thermal bridges here. Good. We like to see this blank in projects. I don't have any attached zones. I could have modeled something, maybe the attached attic or something, but I didn't. And I don't have any remaining elements. So these would be things that aren't really affecting the model, but they're in the model. Maybe an overhang of sorts. So the last thing that I'm going to do is add the systems. Usually, I'd say make one system. And I'm just going to name it whole house. So this is the system that's going to serve the whole house. If you have different zones, maybe you set up different systems for the zones. So in my system, I'm going to add devices. So you see here's the list of systems. I have one. In system 1, I'm going to add 3 devices. Most projects have at least 3 different types of mechanical systems. One, you almost always have mechanical ventilation. Second, you almost always have space heating and space cooling. So I'm going to add a heat pump here and select those 2, and then you almost always have hot water. So I'm going to keep user defined for hot water, and I'll explain more in a bit. So there could be more systems in this, but this is what this house has. Now I'm going to get into distribution. So this is again within the systems. This is how these systems or devices are distributed throughout the home. So I'm going to skip hydronic heating, this first tab here. They don't have hydronic heating. For hot water, I'm going to go ahead and check out the water supply drawings. One thing to note is a lot of people think circulation pipes mean something like on-demand recirculation, which is getting pretty popular, but it's actually not. It's something that's more so seen in commercial or maybe larger multifamily buildings where there's actually hot water circulating for X hours per day, no matter what. It's not a recirculation, or it's not an on-demand system. It's just a constant recirculation system. So if you have an on-demand system, you do not input this as circulation pipes. So we're going to breeze over those 2. We don't need those 2 because we don't have a circulation system. The design flow temperature is the temperature of the hot water within the pipes. I'm going to input 120. As you can see in the hover over, it's 120 to 140. Up to you. For certification, we let you go down to 120. This next input is relative to the circulation pipes. So again, we skip it. We're not using real circulation pipes, even if we might be using an on-demand system. Okay, so the individual pipes. The length of the individual pipes is the sum of the distance from the hot water tank to each individual hot water tap. So what this drawing is the CPHC has summed the distance, or shown the distance from the hot water tank to the kitchen sink, to the tub here, to this sink here, to the clothes washer, and then up over here into the tub, into this sink, the master bath sink, shower, yada yada. And here is the sum of the total length of all those pipes. So it was 8 feet to the bathtub, 12 feet to the vanity, and this is horizontal and vertical lengths here. So the total on the first floor was 66 feet, and the total on the second floor was 136 feet. And this is a pretty compact design here, pretty good design. It's all within the same kind of stack here. So the total I'll be inputting here is 202 feet. And the exterior pipe diameter is usually about an 1/8 inch larger than the nominal pipe diameter. So these are 5/8 inch pipe. So we have about a 3/4 inch pipe, 3/4 inches for the exterior diameter. So I'm going to put 0.75 here. And this is all you need for hot water, unless you have recirculation lines. So that's it. Next, we'll move on to cooling. This project is using heat pumps, so we're going to say cooling via air recirculation. Via ventilation air would be if it was in line with the actual supply air from the ERV. They were ducted together. Panel cooling is like hydronic cooling, I suppose. Yeah, recirculation would be your heat pump. Dehumidification is if you have a dehumidifier, or sometimes you need to check this if the recirculation air alone won't cover the latent humidity or the latent cooling demand. So for recirculation, you need to input the minimum temperature of the cooling coil, which is, we're going to say it's about 45 in this pop-up hint. And then the volume, let's say it's about 200 CFM. So that's all we need for cooling. We're good there. Next, we're going to ventilation. And this is asking about the ducts from the ventilation unit to outside. So that's just these here and here. So this is a pretty good area. You want to shorten these ducts as much as possible to make the ERV as efficient as possible. So I'm going to estimate, just because these might have to wrap inside or something, that these are each 5 feet. And it's really just because we're seeing the projected view, maybe there's vertical distances inside or something. And it's just the distance from the unit to the interior face of this exterior wall. So I'm going to add a supply duct and an exhaust duct here. I'm going to call this exhaust, supply, and basically you'll just be inputting information about both of them now. So for the exhaust, I'm going to enter the duct diameter, 6 inches. This is from a Zender system, so I believe they're 6 inches from the ERV out. Insulation thickness, this is project dependent. I'm going to go ahead and guess there's 2 inches of insulation, and it's R4 per inch. It's EPS or something. And then I'm going to assign it to my ventilation unit, which doesn't have a name yet, so it's V1. I'm going to do the exact same thing for the supply. And that's all I need for the ventilation ducts. This next one is auxiliary energy. I'm going to keep it as default values for right now, but if I didn't, I could add things like heating circulation pump, storage load pump, hot water circulation pump if we had that. I'm just going to keep default for now. Okay, so now that I've defined my systems, what I have, and how they're being distributed, I have to input like efficiency information about the systems. So the first thing I'm going to look at is the mechanical ventilation. They're using the Zender Compo Air 350 ERV. I'm going to pull open really quick Phius data on this ERV. We have new ERV efficiency protocol as of the conference in September last year, and I just took a screenshot from the spreadsheet. Spreadsheet's downloadable from our website as well. It lists quite a few manufacturers, and the adjusted efficiency for Phius modeling is over here on the right. It's all bigger. So this is Zender Compo Air 350 ERV. I'm going to use 81% as the efficiency, and I'm going to use 0.38 watts per CFM as the electric efficiency. So that is these top 2 inputs. The electric efficiency actually will be adjusted once this is measured on site, but this is just a typical value, I guess, for this unit. Equipped with frost protection, yes. We are in New York, cold area of New York, climate zone 6. Under this, you can see here's a list of all 10 rooms that we added on our ventilation rooms tab. We need to assign these all to the ventilator. So just go through and you click and add them all to the ventilator. If you had more than one ventilator, then you would have, or more than one zone maybe, and you're ventilating different zones with different ventilators, you would assign, you know, half to whatever. And that's why you're assigning the rooms ventilated by what particular unit you're using. Okay, quantity, we have 1. Humidity recovery, we will have humidity recovery because it's an ERV. This data isn't given, as far as I know, nope. So I'm going to input 0.4 or 40%. That's kind of a standard value we allow people to use for certification. 30 to 50%, that's usual for an ERV. It is in the conditioned space. This is talking about like a summer bypass, so it's like a free night cooling in the summer. When temperatures are favorable outside, it just bypasses the enthalpy wheel, so it doesn't actually transfer the heat between the incoming and outgoing air streams. We're going to say the defrost is active because we need the defrost, and then it should be used when it's 25 degrees or below outside. That's a certification protocol. You can't input anything below 25. You're welcome to input above 25. But some manufacturers may say below 25, but we stick with 25. They are not using any sort of ground loop or subsoil heat exchanger, so we will leave this at 0. So this is all my inputs for the Zender CompoAir. The next thing I'm going to input is the heat pump. There's this really intense page when you're going to input a compact heat pump, but I'm just going to pick heat pump. It gets significantly simpler. I'm going to call this Mitsubishi. Let's see, I have the unit open here, so I don't need to be too specific about the name. But it's a Mitsubishi heat pump. And I'm going to calculate the COP using a calculator that we often advise people to use in certification. It basically calculates a project and climate-specific COP based on the data given from the heat pump manufacturer at 2 different temperature set points. So this Mitsubishi spec sheet I just had here, zoom in a little bit maybe, has heating data, or has a capacity and input at 47 and at 17. So with that, we can kind of determine what the COP is in between those when we know that those 2 data points. So what I've done here is pulled in the capacity and the input here and done a conversion into the COP. So 13,600, then the conversion factor, and then 950 watts. And that gives me a COP of about 4.2, but that's when it's 47 degrees out. It's about 3.04 when it's 17 degrees out. So what this calculator does is you input your average ambient temperature. This is directly from the climate data here. And then your output for the monthly heating demand. So mostly heating demand is here. It's mostly in, these are months, so it's mostly in January, February, and December. So it determines based on the temperatures in these months what the actual COP will be, or not actual, but a good estimate of the COP for this unit. So that is determined here. So we got about halfway between these 2 values right here. So 3.46 is what I'll be using in my model. I also added these 2 inputs that are in WUFI Passive. So I'm going to add 3.46 here. The total system performance ratio of the heat generator is really just the inverse of the COP. So the hover over here says the energy input over the energy output. The COP is just the complete opposite. So calculated that here, 0.29. And then the annual cooling COP comes from the rated SEER, the seasonal energy efficiency ratio, divided by 3.412. It's a conversion. So that I also had in the calculator at 6.74. That might be a little high. We'll input 6. But usually you use the average of the SEER and the EAR, the energy efficiency ratio, and then divide that by 3.412, but this model did not specify the EER. Okay. So the very last thing we're entering is the heat pump water heater. And I input that as a user defined. Open the spec really quick on this. Pretty good on time right now. Okay, so let's just say they're using this model. I don't think they are, but this is the specification we'll look at. We're looking for the energy factor, which is 2.45. So one thing to note about using both the heat pump for space heat and the heat pump for hot water is that for part of the year, when the heat pump for space heat is working or is on, the heat pump water heater will be stealing some of that heat in order to heat the water. So what you have to do is derate the efficiency of the heat pump water heater by a little bit to account for the fact that it's kind of stealing heat from that heat pump, that space heat pump. There's a long Tech Corner article on this if you'd like to read it. It's the same one that shows the background for this calculation. And I've kind of pulled a screenshot out. Not going to get too into detail. But you use this equation to determine the adjusted, I guess I'll call it the adjusted energy factor for this unit. So what you need is the COP of the space heat pump, energy factor of the heat pump water heater we're using, and then this is the adjusted energy factor, so 1.91. It goes down quite a bit. We assume that it's stealing heat from the space heat pump 9 months out of the year. So it might be a little conservative if you're not actually heating 9 months out of the year. The input in WUFI Passive, again, is just the inverse of the energy factor. So it's the performance ratio heat generator, 0.52. The primary energy factor, this is an electric system, so it's 3.16. That new primary energy factor for electricity. CO2 emissions, I can find this by going to my primary energy CO2 tab. So I find electricity mix here, and it's 199.31. It's within the thermal envelope. And I'm not going to add any additional auxiliary energy. Okay, so it's telling me I have an error. So I thought I was done. Down here in the bottom, I have an error. So I'm going to double click on this error, and it brings me right to it. So I didn't input a duct length for the supply duct. So I'm going to input 5. And lo and behold, I have results. So this project is meeting everything except heating load right now. Well, in primary energy, they're slightly over. We're going to go into the report to look at this in a little more detail. Before we do that, we should look at the ventilation. Looks like we have 0.28 air changes per hour right here. I'm going to increase this a little bit to get to 0.3. So I'm going to change the hours that it runs on maximum. So I'll do 4 and 20. Oh man, 5 and 19 maybe. There we go. So now we have 0.3 air changes per hour shown here for ventilation. And as I said in the beginning about the foundation interface, all this data automatically pulled in now. Now that I've input enough, it knows how to pull this information. So earlier these were blank. Okay, so now I'm going to jump into the report, and then we'll go through it really quick, and then we'll have time for questions. So I'm going to full screen this report really quick. Get out. Okay. So the certification criteria is Phius. Now you see something new. If anyone's used to the old report, there's a target number. This used to be 4.75. It didn't used to exist because it used to be 4.75 for everybody. Now it's the target based on the inputs we had in the original screen with heating degree days, cooling degree days, yada yada. So they're barely meeting this 5.82. Cooling demand, the target I think is actually a bit higher for this location, but as I said in the beginning, there's a slight bug with only this input on the dehumidification design humidity. So the latent isn't considered in this report. Obviously, that's going to be fixed. But I think it's in the 2s. the cooling demand target, but they're still meeting it regardless. Heating load, kind of over by a lot. Target 3.83. Cooling load, target 3.84. Primary energy. This, I don't know if I got to yet, with the Phius Plus 2015 standard is now per person. So the target is actually lower than 38 for this house. The old target, I think, is 38.1 kBTs per foot square per year. It went down to 35, 36. They're over ever so slightly. And I made assumptions about the systems here, so maybe they actually will meet it. I'm not sure. Very, very close. Keep going. Now there's an input for site energy. This is helpful when determining PV offset, which is also part of the Phius Plus 2015 program. And that's basically this. It's a translation between primary energy, the primary energy factors, and the efficiency of the mechanical equipment you're using. Airtightness. Like I said, it would increase quite a bit from 0.6 for smaller projects like this. The target is 1.06 air changes per hour, which is equivalent to 0.05 CFM per foot squared of envelope. So if they're confident they were going to get 0.6, we could probably model with it, and maybe we'd be closer to meeting the heat load or something like that. But they're allowed to get up to this and still certifiable. I'm kind of just going to breeze through the rest of this. This is just an output report of everything else in the project. It's a really great looking report. Heating and cooling demand per month. A lot of heating and cooling, or a lot of heating in the winter months relative to the cooling. Output chart. Okay, lots of graphs. Graph visualizations of these charts. That's usually what that is. Stuff about ventilation, HVAC systems, the electricity demand broken down into different components. So here's the miscellaneous electric loads, that thing we added from ResNet. It really outshines everything else. And we believe it's really a lot more realistic than what we would have usually input. So it gives you an idea of how we're actually calculating loads now relative to how it used to happen. Internal gains, hot water, and yeah, that's about it. I'm gonna exit out of that. And I think I'm ready for questions. Okay, so I can just read them. Click to open questions page. Okay. Okay. Hard to hear. Yeah, okay. I'll get better. Sounds better. I'll start here with the version of Sketchup. Any of the versions of Sketchup work. So that's an easy question. You just have to get the plugin, which you do within WUFI Passive. So the plugin comes with the WUFI Passive software, and then you add it into Sketchup. And we'll have information on how to get that online, or if you email me, I can give you details on that. Q&A. If you need to change a window size, can you alter it within WUFI, or can you do that in SketchUp? I'll show you very quickly how to do that. So you can do it within WUFI. If I can get this out of here. Okay. So let's say, so let's say I want to change a window over here on my west wall. I'm going to go, I'll just full screen it here. I'm going to go into this Windows option, Windows and Openings, and then it shows me the whole wall and then the windows. So one, if I wanted to move it, easy. If I want to change it, change the size, I edit the list of windows, and it gives me a list of all the windows and their current sizes. Let's say I want to, they're all 3 feet right now, and I want them all now to be 5 feet. All of a sudden I want more glass. I can just change the window width here, all to 5. Or you can do this for 1, and then say, okay, now I have all these 5-foot windows. If I just want to change one, I would pick the one I wanted to change and change the width and height to what I want. You can also change the shape if you want something like that. So there's options to edit the geometry within WUFI Passive. The other thing is you can re-import the geometry and it doesn't mess up most of the stuff in your model. So you can change it, and if you're going to make a lot of changes, it might be easiest in SketchUp. It's up to you, but it's pretty easy to use this list feature. Okay. Yes. Next. Yes. Oh, I'm sorry. The cooling degree is base 65. ASHRAE 90.1 and IECC uses 50 degree. This is just, the input is just based on what the feasibility or the economic feasibility study was done on in BIOCT. So it's using these different temperature set points. The inputs you're using are from heating degree days at base 65. Again, you probably won't ever have to input these first inputs I showed you. These are going to come with the climate data. Right now it's not available, but it should be with the next release. But these are just from what the study used. So it's ASHRAE data too, just not base 50. Okay. Yep. Okay. So what about framing? I think I might have briefly covered that. Framing in the assemblies. Okay. So if you aren't entering windows that don't provide the psi values, the psi spacer, I'll go into it really quickly. It has a very small range. So we'll edit really quick. I'm hovering over the spacer right now. So it's approximately 0.023 to 0.04. I think they've gotten a little bit better, so maybe it's like 0.015 to 0.04, but that's pretty much the range, and it says typically 0.023. The frame wall psi value, I kind of got into. This is the installation thermal bridge, and you can use 0.015 for windows that are installed with over insulation in the middle of the wall. If they have one or the other, we recommend 0.02. And if they don't have either, if it's just kind of a window within the framing, not in the middle, no over insulation, we recommend 0.029. Those values are also on the Phius certification guide. Get out of that. Maybe. Okay. What should be done on window data inputs when door sill not the same as jambs and head? Same question for mold or T-million multi-pane windows. You can create different window frames that have, let's say, maybe a thinner profile where the window is mold. You might also be asking about the installation condition, and I didn't actually touch on that. So the psi install, where the window is installed within the wall, that doesn't occur. This question's thing. Okay. For, let's say, for example, these windows on this mullion between the two, there's not that thermal bridge where the window's installed within the wall. So what I could do for this particular window, if they were separated, is change the frame wall psi value down on this general tab. Oop, I accidentally changed the mode somehow. I would say it's not from the window parameter. So in the window parameter, we set it up to have a thermal bridge on left, right, top, bottom. And this is where you change the frame width to. You just make a new one and say the right and left are thinner, something like that. You could remove the thermal bridge on, say, this one for the right, so 0.015 on the left, but the right is 0. Top still 0.015. And the bottom still 0.015. So that's how you would do that. But you need to separate all the windows in order to assign something that detailed. So I'm just going to still do from window parameters. Yes, solar protection will be different for summer versus winter. If there's deciduous trees, that's too much to get into right now. It depends on how close the tree is to the property, what direction it's facing. We can discuss via email if you have more questions. How do you break windows into separate components? Good question. So if I go into my 3D model, I simply select the window I want to break up, and I can either ungroup all selected components or main. So main would just make this window one group and then the rest one group. I'm going to go ahead and we'll just do all. And now all of my windows are different components. So you'll see, so again, just in case I did that too fast. Oh, well, now they're not grouped. If I want to group these two, I would hit Control, and I could group them back together. Or I could do ungroup, off. So now my list is going to be long, because I have all my windows separated, which is fine. That's how it should eventually be. That's how you ungroup any of the components. You can save, you can't save settings within the program, but you can save everything. So the question was, can you save your common WUFI settings for walls, windows, and mechanical equipment as a starting point and just load SketchUp geometry to start a new project, or what the best way is to compare different building geometry performances? I would say just create a big database of different assemblies. What I do for feasibility studies, actually, we'll go into my assembly database, is I just have these generic I think I start at 20, 15, and I go up to R120 in increments of 5. So if I want to just see what I'm looking for in that assembly, I can just pick, I want an R40, I want a yada yada, and then I determine how I'm going to make that wall or how I'm going to make that roof. So maybe that's the best way to do it. So make a big assembly database. You can make HVAC devices in your database. So you can make different mechanical equipment to pull into your model too. Oh, and I lost the questions here there. So that's the best way to do it. I'd say just load up your database and then just simply assign them from the database each time. 8-inch ledger. Skip that. How do you group and ungroup? Good. What is entered when portion of the DHW pipe diameter is different than other portions? Okay. Basically what you do, I'll pull up the hot water. Let's say part of it is maybe 3/4 inch pipe and part of it's 1/2 inch pipe or something, or 5/8. You just do a weighted average. That's what I would do. So if like part of this is off of the main trunk, then I would say, 4 feet of it is 3/4 inch, 4 feet of it's 1/2 inch. So I'm going to weight it, and then that's how you determine the exterior pipe diameter. So yeah, circumference weighted. Yeah, there's no difference between copper and PEX piping for hot water distribution. Maybe the exterior pipe dimension will be a little bit different. Yeah, there's a little more complicated when you're using on-demand recirculation, but I would refer to the Phius certification guide for that. If you're using an on-demand recirculation, you can use a reduction factor for the total length of individual pipes, but that's something a little too detailed for right now. I wish I could elaborate on how Revit can be used in WUFI Passive. It can be used in the same way as SketchUp. I don't personally have Revit, so I haven't imported it, but I do know quite a few CPHCs that work hand in hand with Revit and WUFI Passive now. If you contact me via email, I'll give you maybe put you in contact with someone that uses that often to see if maybe you guys can work together, or they can give you some hints on how to input that. We will have that up on our website soon too, from Fraunhofer, the specific details on how to upload that. But it's the same way that SketchUp works. Basically, there's a plugin, you assign the components different properties, and then you upload it. The hot water defaults did not change. 6.6 gallons per person per day is the same. WUFI Passive is still a Windows program. That has not changed, as far as I know. Yes, Lois, the static version of the software will be free. That will come out again sometime before the end of the month. I also think there will be some dynamic capabilities, but not like hydrothermal modeling or anything like that, but maybe like comfort assessment. I'm not sure quite yet what all the limitations will be. Yes, thank you, Dan. So Dan was the CPHC on this. Okay, so the foundation walls, some of the things differed a little bit from the actual project. I think I thought that you were changing to 6 inches of foam under the slab instead of 10, And I knew the solar heat gain was different on the south windows, but because we grouped them all together, I used the medium gain window. This is a good question, this next one. So covered porches in the Sketchup model. Does WUFI recognize these as shading devices? So there's this porch on the front of this project. See if I can get it to show up over here. If I would have added this into the Sketchup model and into WUFI Passive, would WUFI Passive know? And the short answer is on the static side, not yet. It will soon, but right now you still have to input it as an overhang. But pretty soon, within the next release or two, the capability of the dynamic side, which can actually calculate based on the building geometry, will be included into the static side. So it'll actually calculate based on your building. So that'll help too if you have like funky building geometry with like bump outs and all of that. It'll get significantly more accurate, and you'll be able to model these overhangs and not worry about inputting different values for the overhang. So soon. We're really looking forward to that. Okay, so all the Phius, yes, all the Phius Plus certification metrics are based on the new conditioned floor area measurement. The certification guide is on our website. I can jump to it. I only have a couple more questions. Okay, while that's loading, it's on the certification page of the website. I think there's a getting started area. It has a Phius certification packet, which basically outlines everything you need to submit for certification, and then the guide. If you're using WUFI Passive for the first time or at all, I would really recommend downloading this. It literally goes in the order of the branches of WUFI Passive and tells you all the certification protocol about all of these items. Very helpful. If I can get to that, let that load. Is there an ability for lighting controls to reduce lighting electrical energy through daylight harvesting or occupancy sensing? Not for residential right now. For commercial, yes. Or not commercial, but non-residential. I guess commercial, yeah. They do have inputs for daylighting, or I guess it assesses the feasibility of daylighting based on the room geometry and occupant sensors. Right now, there's not the ability to control that. Right now, we just use 80% of ResNet. This might be up for change if we evaluate it and think there's better ways to model it, but for right now, we use that as a baseline. Where do you input results of lower door test? This comes in, let's see, in the pH case additional data. And here I put the infiltration per square foot of envelopes, so 0.05 CFM per square foot of envelope. I could change it to ACH 50 if that's the data I got. And let's say I got 0.6, 0.7, I don't know, whatever. That's where you would input that. Or you can use the result in CFM per square foot of envelope. So that's where you input that. Why do you always measure a home run to the water heater? The old assumption, or the assumption with the hot water, is that each tap is turned on 3 times a day. So water travels that distance 3 times a day. So it pretty much figures out the volume of water that fills that individual pipe, and then the energy required to heat that water from the incoming water temperature to whatever the circulation temperature is. So like 50 to 120. So it's just figuring out a volume of water and the energy associated with heating that water. And it's an estimation that tap is turned on 3 times a day. Is the Sketchup plugin on the WUFI website? No, it's actually within the WUFI software. So I'll show you really quick. It comes in this options, Sketchup plugin. And basically you follow a few steps in here. I already have it. But you follow a few steps in here. So once you get the free version, it will come with it. When's the next WUFI Passive release coming? How do we find out about future releases? Okay, so this is something else. Try to exit that. In the new version, I think it's in the options. Okay. And the options, I just clicked on the options up here on the top, English IP/outer dimensions. It has a checkbox for check for updates when program starts. This is new. This is really important. Check that. So then it's like other programs, when you open it, it'll say there's a newer release. Do you want to update? You'll either find about it then, or Phius will announce it. There'll be some sort of announcement. I understand in the past it's been a little bit slower at getting the updates, but everything should be on the website too if they have a newer update. Okay. Did I lose it? Okay. Yes, the webinar recording will be accessible online on the Phius website. If we are a Mac only office. So is there an option for Phius Plus certification if you're a Mac only office? If you get Parallels or something where you can download WUFI Passive, then yes. Right now we're still accepting the PHP and for the foreseeable future, which can be used within WUFI Passive. I'm 2 minutes over right now, so I'm going to breeze through these next ones. Oh, same question. Will Phius continue to accept PHP for certification? Yes. For the foreseeable future, again. Eventually we will phase it out as these two programs kind of diverge even more. Right now we're already kind of diverging from the PHP with the new WUFI Passive software, and it'll be a little more difficult to find your targets and everything within PHP. So it'll just become easier to use WUFI Passive for Phius Plus certification. What prevents the designer from providing too little window area? Nothing. For example, yeah, so you can't consider some things bedrooms if there's not legal egress and a large enough window, but nothing in the program really prevents that. We don't break it into bedrooms. That's kind of just on the designer. Yes, the webinar will be recorded. Yes, I will get back to the website and show the link to the Phius certification guide. And yes, and maybe, I'm not actually sure about if there's ways to run parametric analysis with the software. I haven't. And I think that's the last question, so I'll really quickly show the link to the certification packet. So I'm on the Phius certification for buildings and products. I'm going to go to, I think it's submit. I'll just click on Phius Plus 2015 project certification. Okay, so it must be under submit a project over here on the left. And then documents getting started. So here's the Phius Plus 2015 certification packet. Here's the guide. The guide is the one that I said has a lot of the energy modeling protocol. And then here's the ERV HRV modeling protocol that I got that screenshot from for the ComfortWare. And I think that was it, but I lost my question box. Yep, that's it. So thank you everyone for listening. If you have follow-up questions, you can email me, lisa@passivehouse.us. Be happy to answer. And I hope people will attend more WUFI Passive webinars in the future as we start to adapt this model to more CPHCs that maybe have learned the older model. I think you'll really find that it's very user-friendly and great to run multiple iterations in. And everyone have a good night.